Now that we are definitely motivated about the cells division, let's start to talk about some linear algebra to try to get more tools to handle this kind of problems. Let's start to remember what's the definition of a vector space. A vector space is a non-empty set such that, so a vector space over the real numbers, it's a non-empty set such that the vector addition satisfies these properties. So vector addition is some operation between two vectors which are, by the definition, two elements of the vector space. So if this element satisfies the commutative, which means that the sum is can be reversed, doesn't mean the order doesn't mean, or it can be also associated, and there is also some neutron element, which means that the sum by these numbers, any vector that are summed by this number has as a result the vector itself. And the fourth, actually this one is more a consequence. So this fourth you can prove using the other three. So that there is a symmetric element such that this happens. Okay. And another property of a vector space is the scalar multiplication. So now this is an operation between a scalar, which is a number. A scalar is just a real number, or it could be a complex number, but we are talking here about vector space over the real set. So it's a multiplication of a real number by a vector. So it needs to satisfy these properties. This one, which doesn't matter the order that you're doing, and also the distributive, and also another way of distributivity, and the neutron element of the scalar multiplication. So this is the definition of a vector space. And what is a subspace? A subspace, S, is a non-empty set of a vector space V such that, so S is a subspace of V if and only if, which means that if these three things happens, it implies that S is a subspace of V, and the other way around. So the first one, the zero element is contained in the S. If you have two elements x and y in S, the sum should stay on S, and also given x in S, for every a, you have that a times S also belongs to S. So I give here below some example. So the question is the set S a subspace of R2? So first, we have that 0 belongs to this set. Yes, because if you take x equals 0, then you have that 0, 0 belongs to S. And then 2, let's look for the second condition. So suppose that x and y belongs to S, and let's sum 2 elements of x. Okay. It will be equal plus y, 2x plus y. So which can x and y, x plus y belongs to R. Here x plus y belongs to real. So the second one is satisfied, and let's look for the third one here. So suppose that x belongs to S, and let's get some a times some element of x, which is in this way, which is equal ax, 2 times ax, and ax belongs to real. So the conclusion is yes. The answer is yes. S is a subspace of R2.